Hello everyone, this is Alan C98 and welcome to the second in my series of videos on my Dryer IoT project, otherwise known as DryOT. In this video we're going to cover all the operating system and software library setup. So just a quick overview of the project. My project DryOT is an Internet of Things laundry room monitor. We're using the Raspberry Pi Zero W with wireless and the Pimoroni EnviroPHAT for sensors. And of course this project is going to be attached to my dryer so I can monitor the dryer and most importantly tell when it's running. In the first video we covered the project introduction where we talked about all the project goals, what we're trying to accomplish, and then did the hardware build. So just a quick recap of the project goals. We want to monitor the motion sensor on the EnviroPHAT to tell if the dryer is running or not. We want to monitor the temperature in the laundry room just for another data point to look at. And we want to be able to tell if someone left the lights on in the laundry room by monitoring the light level using the EnviroPHAT. And a future goal is to add a Raspberry Pi camera and try to be able to detect the estimated time remaining on the dryer cycle. Okay, so the main focus of this video is to do all the software setup, which includes installing the Raspbian Linux OS on the Raspberry Pi Zero, connecting it of course and powering it up, going through all the Raspberry Pi setup, which includes setting the locale, the network, our password, setting up remote access through SSH, connecting it to I2C so we can talk to the EnviroPHAT. We're going to do a complete update of the system so we have all the latest software. Then we're going to install all the Python libraries that we need so we can talk to MQTT and Adafruit.io. Then finally we're going to install the Pimoroni EnviroPHAT software. And then we're going to give the EnviroPHAT a quick test so we can make sure it's all working and was put together correctly. Finally, in the third video, we're going to do all the programming, the custom work that we have to do to actually make this project come to life. So we have a lot of setup to do, so let's get started with that. Okay, so the first part of our software setup for the DryOT project is to download and install the Raspbian operating system on our Raspberry Pi Zero W. As you can see on my webpage, I went to the raspberrypi.org website, and now I'm going to go to the downloads section of that website. We need to download Raspbian, so click on Raspbian. And we also need to select Raspbian Stretch Lite. This is the smaller version of the operating system that doesn't have the graphical user interface, desktop, and all the desktop programs and games. We just want the bare minimum, which is still actually pretty big. It still includes a lot of software, but that's what we're going to choose. So just click on Download Zip, and let's start the download. You can see it's cranking away down here. It's got about 25 seconds left, so let's let that download. And while we're waiting for that, let's start another download. I have this other browser tab open to Balena, I believe I'm saying that right, .io, and we're going to get a program called Etcher. So let's go over here to More Products and choose Etcher. Etcher is the program that we use to write the Raspberry Pi image to the Raspberry Pi's SD card. So we'll download this for Windows. That's the operating system I'm using right now. They also have a version for Mac OS and Linux, depending on what you're using. And so we have the Balena Etcher program ready to go. I've actually already installed it. You just have to run the setup program. Now we just need to wait for the Raspberry Pi image to finish downloading. For when we get our Raspberry Pi image, then we can write it to the SD card. So let's see, let's open it. And inside the zip file, we have the actual disk image file. So let's extract that. We'll just put it over somewhere like on the desktop. Okay, so it's copying to our desktop. Then we'll need to open the Etcher program so that we can write the image to our SD card. All right, that's on the desktop. So let's run Etcher. So we go up here, run Etcher. So here's Etcher. We have to select the image. Go to Desktop and select the Raspberry Pi Raspbian Stretch Lite image. Click Open. Now it says select drive. This is where we have to be careful. I don't have my SD card in yet, so let me put the SD card in. Okay, I put the SD card in. I'll select the image. Here's where I want to select our 16 gigabyte SD card, the micro SD card that I got for this project. It already has a couple of partitions because I tried installing the OS earlier. So this is what we want to use. This is where you have to really be careful. And Etcher gives you some hints here where it tells you, hey, don't select this. This is a large drive. So if you select this, you could wipe out your operating system on your computer. So make sure you're using your SD card and not one of your hard drives. So let's continue. So we have our image. We've chosen the correct drive, the SD card. Now we just need to hit flash. And of course we have to give it permission to write to the device in Windows. So hit yes, and then just wait for that to finish flashing. Okay, looks like it's finishing up. Now it's going to validate the image to make sure that the data was written to the SD card correctly. Okay, so we're finally finished, and you can see this little pop-up came up here. We want to ignore that. So flash is complete. So we have the SD card image programmed. We're ready to move to the next step, which is to hook up the keyboard, mouse, and monitor, install the SD card so we can boot the Raspberry Pi for the first time and complete the setup on the Pi itself. Okay, now that we have the Raspbian Lite image programmed onto our micro SD card, we need to assemble everything and get ready for the first boot and configuration. So we have our project here with the EnviroPHAT, the Raspberry Pi Zero W board, and of course the 3D printed mount that we made. So now first thing we need to do is plug in the micro SD card into the Raspberry Pi. That's pretty easy. And now we need a mini HDMI connector. So we plug that into the Pi, and then we can plug our HDMI cable from the monitor in here too. We're only going to need that during setup, of course. We're not going to have a monitor connected to the project when it's running. Next thing we need is a way of setting up the Pi. We need a keyboard and mouse. So I plugged this little micro USB to regular USB adapter. And I'm going to use my little wireless transmitter for my Logitech keyboard and mouse combo here. So I just plug that in. That works very well with the Raspberry Pi. It doesn't need a driver or anything. And this is the keyboard that I'm using. Okay, so now we have everything we need to start the Raspberry Pi setup. So the next thing we need to do is apply the power here by plugging our micro USB power supply into this Raspberry Pi, and then we'll get the process started. So now you can see the lights on. It's starting to boot up. So let's switch to the Raspberry Pi display, and I can walk you through what you need to set up Raspbian OS for this project. So when I first boot up the Raspberry Pi with the fresh SD card image, the first thing it's going to do is it's going to resize the SD card image and then reboot. That will give me the extra space on my 16 gigabyte card. So let's boot it up for the first time here. And you can see it booting. It's going to resize the image and then reboot. Now it's going to come back and actually boot up with the resized SD card. Okay, we're still waiting for the first boot to complete. And once it is finished, we can log in. So let's log in using the default username and password. So we're going to type in Pi and then Raspberry, RASPBERRY. And so now we have our first login after we booted up on the fresh Raspbian Lite image. And we're going to do all the setup we need to do. Okay, so what we need to do to start our setup is we need to type in sudo. And sudo is the command we use when we want to run something in root or privileged mode, sort of like the administrator on Windows. So we need to type in sudo raspi config, hit enter, and we're going to get a menu system. So the first thing we need to do on our setup here is very important, and it keeps tripping me up over and over again, is set the localization options. So I want to go down here to 4, choose localization options, and the most important thing for me at least is setting the keyboard layout. Change keyboard layout. And we have to give it a minute here. And we want to choose generic 101 key PC. And of course it's set for English UK, and this is what gives me the problem. When I type my Wi-Fi password, one of the special characters I hit ends up being like a UK pound sign, so then it ends up not giving me the correct password and I can't get on my Wi-Fi. I keep doing that, and I finally realized that I have to set the correct keyboard layout first before I try to connect to Wi-Fi. So let's go down here to Other. And I want to use English US. And I want to go up here to English US. And I'm just going to choose the default options for these next 2 items. It's not really that important. I'm not using this as a desktop PC or anything. I just need to have the right keyboard map for setting passwords. Okay, so now that we have the right keyboard map, we can actually change the password. And if we're on the network, it's very important to change the default password from the Pi user. So let's do that now. I'm typing in my secret password. Okay, password is changed successfully. Okay, now we're actually going to set some more localization options. So let's go down here and choose this. And we want to change the time zone. We've already changed our keyboard layout. Okay, go down here to US, because that's where I am. You know, obviously set the time zone for where you are. And I'm on the East Coast, so I'll choose Eastern. So now I have my time zone set. Let's pick a couple of more options here. Go back into localization, and we're going to change the Wi-Fi country, because that'll be important when we want to set up the Wi-Fi. So I have to go all the way down here, because again I'm in the US, so I want to set that as my Wi-Fi country. Okay, there's United States. Select that. Wi-Fi country is set to US. One last thing in localization. So once we have all these set up, then we shouldn't have to change them again. Let's change the locale. Okay, I want to go down here. It should be set to EN, which stands for English, GB, which I believe is Great Britain. And I'm going to change it to EN US. Okay, there's GB, UTF-8. Deselect that. And I want to go set it to EN US. UTF-8 as well. Okay, select that. Hit OK. I'm going to choose that as my default. It'll take a minute. Raspberry Pi Zero W isn't the fastest processor, so sometimes these things take a little bit of time. Okay, so we have the locale set, all the localization options we want. We want to set the network next. So we're going to try to set the host name and connect to a Wi-Fi access point. So let's set the host name. Let's make this match our project instead of having generic Raspberry Pi. Let's make it DryOT. Okay, host name is set. Now let's connect to the Wi-Fi. Go here, select Wi-Fi, enter SSID. So I'm going to enter in the SSID or the Wi-Fi name of my Wi-Fi network, RC Net 2. Of course, yours will be different. Now it's asking me to enter in the passphrase, so I'll type in our password. Of course, that's my Wi-Fi password, not my Raspberry Pi password. Hopefully I'll be connected to the network now. I'm not sure. We're going to have to double check. Okay, that should be it for network options. The last thing we need to do is select some interfacing options. So let's go here. Why don't we enable the camera? Even though we're not going to have a camera set up on this project, we might want to add one later, so it doesn't hurt to enable it. So we select camera. Yes, we want the interface to be enabled. Go down to interfacing options again. We want SSH because after this, we're going to be SSHing to the machine or to the Pi itself to control it remotely. And we want to be able to log in and do updates and change things. So let's enable SSH server. Yes. Okay. Go back down to interfacing. We need to do a couple more. We need to enable I2C because the EnviroPHAT sensors, they use I2C to talk to the Pi. So let's select that. Yes, we want to enable I2C. And we don't really need SPI, but it probably doesn't hurt to do it anyway, just in case we wanted to add on another sensor or something that used the SPI interface. So let's do SPI as well. And of course, this setup would apply to just about any Raspberry Pi project that you want to do. Okay, so I think that's about all we need here. So let's finish up. Type finish, and it's going to ask us if we want to reboot, and of course we do, to make these changes take effect, and then we'll see if we're successfully on the network. So let's reboot. Okay, so now we're rebooting the Pi after getting all of our settings done with the Raspberry config program. Hopefully we'll be on the network when we log back in. So let's wait for it to boot now. Okay, looks like it's finished booting. Waiting for us to log in with our new password, and I can see that it says my IP address is 192.168.0.226, so we are on the network. So let's log in. Pi, and I want to use my password I set. Okay, we're in. Now let's look at a couple of things. Make sure we have the date and time set up. So I'll type in date, and it tells me that it is the correct time, Eastern Standard Time for me. And let's ping something, make sure the network's set up. Ping google.com works. Hit Control-C there. So the last thing we're going to do on just the basic Raspbian setup is just update all the packages. You know, this operating system was released in November of 2018. It's now February, so there's been a number of security updates. So let's update everything before we move on to the project-specific software setup. So we need to type in sudo apt-get update, and that'll have it go out to the servers and get a list of all the latest packages to see what it needs to update. And even if we have this little Raspberry Pi running in the basement, stuck to the dryer, sitting there running, you know, for weeks and weeks at a time, it probably would be a good idea to just get on there every once in a while and do an update like this. You can probably set up to do it automatically once a week or something as well, but I haven't gotten that fancy yet. Okay, so it's finished getting a list of updates, so let's let it do the updates. I'm going to hit up arrow. And instead of update, I want to type in upgrade to upgrade all the packages that have been updated since. Okay, type in yes. and we just need to wait for it to complete. Sometimes this takes a couple of minutes. Finally finished updating. That took a few minutes on the Raspberry Pi Zero. It's a little slower than the other models, and of course much slower than a desktop system running Linux. So now we have an updated system. We have the network connected. We have SSH installed. We have I2C ready for the EnviroPHAT. So now that's all the generic Raspberry Pi setup we need to do. So the next step is going to be to set up all of the project-specific stuff, like the Python libraries we need for MQTT, the EnviroPHAT software. And once we do that, then we're going to start writing our programs for this project. So we still have a little ways to go, but that's the first part. And that setup is actually nice and generic for any Raspberry Pi project you might want to do. Okay, on to the next step. Okay, now that we have the Raspbian OS installed and the devices on the network, we need to take this device downstairs, attach it to the dryer, power it up, so we can connect remotely to it and continue the rest of the software setup from the convenience of my desk. So let's get this downstairs. So here's where we're going to put the project. I'm going to stick it right onto the dryer like this. Let's put it here. Stick it down there using the suction cups. Let me get a better view of that. Then we can plug it in up here. Lighting isn't too good down here. So now the Pi is booting up, and then we can do the rest of our setup and software installation and programming remotely. So that's the next step. So now that we have the DryOT project installed on the dryer and it's on the network, we can just access it remotely. So from here on, we'll just be doing all the setup from my PC. So I'm using this program called SmartTTY on Windows. There's a number of ways to use SSH, which is the remote shell to a Linux system. So I'm going to choose Quick SSH Connection. We're going to type in pi at, and then you have to know the network IP address for the Pi that you set up on the network. So after you get your Pi connected to your wireless router, you need to know what IP address it was assigned. In my case, it's 192.168.0.226, and we'll give it the password that we set. Okay, and it says start with a smart terminal or a regular terminal. I'm just going to use a regular terminal. Okay, so now we're logged in from the comfort of my PC while the Pi is actually down in the basement. So in order to continue with our setup, we need to install a few things. In terms of MQTT, you need to have a broker somewhere. You can have a broker on a server somewhere in your house, or you can actually install the broker right on the Raspberry Pi. This is what we're going to do now, because I'm not sure how I'm going to have my MQTT brokers set up in my house. So for this project, I'm just going to install it right on the Pi. So let's type in sudo apt install Mosquito, and we're using the Mosquito MQTT broker. And it's really easy. Just type that in and wait for it to install. You have to hit yes because it needs a few extra packages. Okay, we also need MQTT clients, so let's install those. Sudo apt install Mosquito clients, and then we're going to have to hit yes for that as well. Okay, so this will give us the Mosquito broker and the Mosquito command line clients for us to test things out. Okay, those are done. We need to install pip3 for Python 3. So we type in sudo apt install Python 3 pip. Okay, it has to get a bunch of other things. We have to wait for those to install. Okay, it looks like it finally installed pip3, so now we can install a few of the packages we need. We're going to need to install the PAHO MQTT Python libraries. So to do that, we need to type in sudo pip3 install PAHO, if I can spell it correctly, MQTT. Okay, finally got that. So now we have the Python libraries needed to send messages over MQTT. So the next thing we need is the Adafruit IO Python libraries, because we're going to be also publishing the data to an Adafruit IO account. So let's type in sudo pip3 install adafruit.io, or not .io, but adafruit-io. And that should give us the Adafruit IO client libraries for Python, because we're going to do everything in Python, because as we'll see, the EnviroPHAT has some nice Python libraries available. And we're going to do everything in Python, read the data from the EnviroPHAT, process the data, and then publish it to both MQTT on the local server and to Adafruit IO. And if you don't want to use Adafruit IO, you can always just comment that part out of the script, and I'll have all the Python scripts that I develop will be on my GitHub account. Okay, so we have Adafruit IO libraries. So the last thing we need for the software setup in libraries is the EnviroPHAT libraries. Now I don't believe that's available on pip, but you can see here on the Pimoroni help page, getting started with the EnviroPHAT, it tells you how to assemble the board. And it looks like their solder looks a little bit better than mine. And here's the instructions for installing the software. So you basically have to get this script and execute it. And we don't have to use sudo for this, because I believe it installs everything in your local user directory. So let's switch back and type in that command. Curl https get.pimoroni.com EnviroPHAT, and then we use this character, which is a pipe in Unix, and it'll pipe the script to the bash shell. And so essentially it's going to download and execute the script. Okay, it says, always be careful when running scripts and commands copied from the internet. Ensure they're from a trusted source. And I've used this before for the EnviroPHAT, so I trust it. Okay, so it says it requires I2C communication, which we already set up. So do you wish to continue? Yes. Does look like it actually does install some programs. I don't think it installs everything locally, because otherwise it wouldn't need to update apt indexes, which is the package system for the Raspbian OS. So after it finishes thinking and installing this, we'll be able to do a quick test and make sure that we actually have our EnviroPHAT functioning properly and have everything set up, because you don't want to go any further if the actual sensor board isn't working. So we'll be able to do things like run a quick script to see what the temperature is and things like that. Okay, so it says EnviroPHAT comes with examples and documentation that you may wish to install. Performing a full install will ensure these resources are installed, along with all required dependencies. It may, however, take a while. Do you wish to perform a full install? Yes, we do, because we want the examples. Okay, it looks like the EnviroPHAT install finally completed. It looks like it also had to install the Git version control system clients as well. And Git is something that we'll need, because when I have some example programs to run this project, you'll be able to download them as well using Git. Okay, so it looks like we have everything we need. And let's take a look at the examples. So they're in the Pimoroni directory. Let's switch to that. Let's just give it a quick test before we move on to the next phase of the project. Go into examples. Let's try temperature.py. So let's run Python 3 temperature.py. And you can see that it is reporting temperature, 25 degrees Celsius. I have to see what that is in Fahrenheit, but it is in my laundry room, and I know that this tends to read a little bit high when it's sitting on top of a Raspberry Pi because of the heat that the Pi generates. So we know the EnviroPHAT is soldered and working correctly. Let's see if there's anything else we can run really quickly. There's a script called all. Let's take a look and see what it does. Looks like it'll read light values, altitude, temperature, pressure, RGB, motion heading, all kinds of stuff. Let's just try running it and see what happens. Python 3 all.py. Okay, so it's basically giving us all the data from the EnviroPHAT. The RGB light sources, the pressure, altitude. I'll have to check and see if that's right or accurate. It says it's 104 meters in altitude, and it has accelerometer values. Of course, the dryer's not on right now, so you can't really see much going on. So it looks like it works. So we have everything we need to start programming. So the next part will be to actually start programming this to do what we want, which will be detect if the dryer's on, report the temperature, the state of the dryer, and the state of the lights in the laundry room, and report that all to MQTT and Adafruit.io. Alright, so stay tuned for the next video in this series, where we're going to do all the programming so we can monitor the dryer temperature, the lights in the laundry room, and whether or not the dryer's on in this DryOT project. I'll show you how to do all of that, and I'll have the programs available on my GitHub account. If you're interested in my earlier videos, I have a couple of MQTT tutorials, and I have the first video in this series where we talk about the project goals and then do the hardware build. Okay, so thanks for watching, and I'll talk to you in the next video.